Hello and welcome to my presentation. I'm going to introduce you to the topic of physics in the application of how aircraft travel. Thank you for joining my presentation today. When it comes to the physics of aircraft in the real world, there are four important forces to discuss: a drag force, lift force, thrust force, and weight force. A drag goes the opposite of the airplane's movement and is given by air resistance. Lift is the force that helps the plane stay up in the air and goes about a 90-degree angle of the relative motion. The thrust is the force that travels forward and opposes the drag, and it takes place due to the energy made by the rotor or propeller. The weight is the force that intends to approach the Earth's center. When it comes to the scientific method of how airplanes work, the drag force and the force of gravity have some scientific method information to take note of. When it comes to the drag force, a rule to think about with designing aircraft would be to aim for stable airflow around the entire structure, or plan a very nice aerodynamic design model. When it comes to the force of gravity, designing aircraft would mean that engineers should work on building planes based on the aircraft's weight using various mathematical formulas to determine the proper wing size, speed, traveling in the air, and at the end to create a proper intensity of lift force. Classical physics of how airplanes travel. We can go over the Newton's laws of motion and aerodynamics. The Newton's laws of motion include the first law, which is inertia, or how objects will continue or stop movement. Second law would be the object's weight, or the focus on how an object's weight will impact its speed. And the third law would be opposite forces, or that all forces will have an opposite force of the same strength. When it comes to aerodynamics, lift and thrust forces are two basics of airplanes to operate so they can travel in the air. Airplanes count on the wings for the lift so they can go up. And the engines will be used for the thrust or the forward force of an airplane. A great use of quantum mechanics for the aviation industry would be quantum computing. Some objectives or great uses could be determining the most cost-efficient aircraft routes or digital modeling and simulation. Big companies that want to be involved include Airbus, NASA, and Lockheed Martin. Airbus especially has a big interest for cryptography applications and a variety of businesses such as communications, defense, and security. And the quantum computers allow designing atomic clocks that are more precise for purposes of data transmission control, time controls, and more communicated information. Introducing how airplanes operate, they rely on three control systems: the ailerons, elevators, and rudders. They are important for controlling the aircraft's altitude, and pilots will use these three control systems for aircraft navigation. The ailerons are for roll control, elevators are for pitch control, and rudders are for yaw control. A couple of personal experiences I've seen when traveling to another city by airplane include seeing clouds in the sky through a closer view from an airplane window and encountering the reality of turbulence. Passing clouds, they're interesting to see in a closer view, but are also interesting in that they do drop from the sky, but much slower compared to rainfall because they are mostly a form of gas due to their exposure to intense gas molecule energy, which, due to their buoyancy, it will lead to clouds taking much longer to just drop a little bit from the sky. Moving on to turbulence. Yes, that is a reality regardless how often we travel, and examples of effects could be sudden bumpy movements or a significant drop or plunge. A cause of turbulence would be scientifically moving air currents that travel among regions with various temperatures or when multiple air sections travel different directions. Consequences of turbulence include injuries or fatalities because of not properly secure luggage that could strike other people, and if passengers are not taking safety measures by putting their seatbelt on. In terms of modern technology, airfoil technology was used even way back when the Wright brothers started flying an airplane. And even still today, airfoil technology is used for today's aircraft. However, unlike way back, these days it is prepared well with aerodynamics. Today, aircraft are designed with metal and have a cabin to allow people to sit in. Basic planes go up in the air about 7 miles, and the largest aircraft can make their way about half of the entire world. Even with plenty of differences between planes now and from way back, the same science still applies when traveling in the air. We went over a lot of details about learning physics when it comes to aircraft that operate and travel in the air. Thank you for watching my presentation today.